How's it going, guys? Today I want to go over another LeetCode question, and today we're going to go over a question called flip game, and this is a question that's currently being asked by Google. Alright guys, so today our problem is called flip game. Again, it's a question that's being asked by Google, and our problem description says, you're playing the following flip game with your friend, given a string that only contains these two characters, plus and minus. You and your friend take turns to flip two consecutive plus signs into two consecutive minus signs. The game ends when a person can no longer make a move, and therefore the other person will be the winner. Write a function to compute all the possible states of the string after one valid move. Okay, so in a nutshell, we're playing some random game with our friend where we have to flip plus signs to minus signs. We're given some initial state of this game, and it's our turn, and we have to return all the possible board states or game states of this game after we've decided to make a certain move. And so basically we have to simulate making all the different moves we can. So it also tells us as a note, if there's no valid move, return an empty list. Okay, so again, that's really kind of the logic we're going to go with. We're given some string. We need to find all the possible moves we can make. So what does that boil down to? Well, we know a move requires having two consecutive plus signs. So what this really boils down to is us going through this string, finding every single place where there are two consecutive plus signs, flipping them to minus signs, right? So making that new board state that we would get from making that move and adding it to our list, okay? So that's all it is. It's not that complicated. It's not that bad. Let's start writing our code. So we're going to make just a list of strings to return, and we're probably going to call that possible states because I think that's what makes the most sense. That's what it's going to hold. So we're going to say list of string possible states equals new array list. And again, possible states is just going to hold all the possible states that this game can be in after we've decided to make any of the moves that we could potentially make. So now we need to actually go through this string and find those two consecutive plus signs and simulate making all those different moves. So I think an easy way to do that is we could just have a while loop and say, while we haven't reached the end of the string, keep looking for these consecutive plus signs. So we're going to have a pointer, right? We'll have I that starts at the beginning of the string and moves through the string, finding those potential moves that we can make. So we're going to say int I equals 0. And now what we're going to do is just have that loop. So while I is less than s.length, we need to keep looking for these different moves that we could potentially make, right? So now what do we have to do? Well, if this is the very first time that we're looking through this string, we need to find the very first occurrence of any two consecutive plus signs and simulate making that move. But, and this is the little, I feel like the tricky thing about this problem is if we're on any other subsequent iteration of this loop, we need to make sure that we're not going to simulate making that same move. So let's say it was the second time this loop runs. We don't want to try the first pair of plus signs. We want to try the next pair of plus signs. So to do that, we're going to have a ternary. So we're going to say int next move. And this is going to represent the index or the starting index of those two plus signs that we're going to simulate making that move for. So we're going to say we're going to set this equal to if I is 0. And if I is 0, we're just going to say give us the index of the first two plus signs. And otherwise, we want the index of the next two plus signs. So we could just add another parameter, I, and all that's saying here in this second call is if I is greater than 0, give me the next two consecutive plus signs. So meaning after whatever our current index is of I, right? So from where we just were, look past that. Start looking past that. Great, so now we're hopefully going to have a next move to make. Now we just need to check that we actually do. So if index of can never find two consecutive plus signs, next move is going to have a -1, which isn't a valid index in Java, so it's basically telling us like, hey, I couldn't find what you asked for. So if next move is equal to -1, then we simply know, okay, there are no other consecutive plus signs, we have no other moves to make, so we could just finish our problem right here, right? Let's just return our possible states. And otherwise, if we don't trip that if statement on line 7, guys, that means we definitely have a move, so now we just have to simulate making that move. So to simulate making that move, we need to take the two consecutive plus signs that we found and flip them to minus signs, and then add that resulting state to our result, right? Our possible states that would result from us making that move. So now let's build that next state. So we'd say string, and this probably be something like next state, right? Because that's what we're computing. What we want to do is everything before us is going to stay the same. right? Because we didn't touch any of those plus signs or minus signs or anything. So we could just add whatever was before our move. So s dot substring from 0 up to our next move. So that's going to get everything from before wherever we're trying to make that move and just throw it into our string. And then we want to add the two characters that we're changing, right? So the next two characters were plus signs and we need to change them to minus signs to tell, you know, our opponent or whoever we're playing that this was my move. And then afterwards, we didn't touch anything else on the board, so we just need to add whatever comes after those two plus signs that we're now changing to minus signs. We need to take that and also throw it into this next state. So we could say plus s dot substring, and now this is just going to be our next move, right? So everything from the index of our next move, or the move that we have now just made essentially, or are making, but we want to say plus 2, right? Because we don't want to get those two plus signs that we're changing to minus signs. So we say plus 2. And now we just need to add that next state that we created to our possible states. So we'll say possible states dot add our next state. And now we just need to make sure that we update I, right? Because on the next iteration of this loop, we need to make sure that we're moving forward through the string. So we're going to set I equal to our next state plus 1, right? So next state is going to be the beginning index of our next move. And we want to make sure that we're moving 1 past it, so that we could then find the next move in the next iteration of this loop. Now finally, when this loop terminates, guys, all our work is done. We really just have to return our possible states. So now quickly, let's talk about our runtime. And it's a little bit convoluted, it's a little tricky, but I'm tempted to say that the runtime is O of n here, but I think because we're going through all the characters in the string, that seems like it's O of n. But then I think this substring call, these two here, really just one of them is enough to do it, I think is going to make us degrade this runtime to O of n squared. I'd love to hear what you guys think in the comments, but I think that the runtime is probably O of n squared because of this substring call inside of this loop. In terms of the memory complexity, I think it's basically O of n. I think it's technically a little bit less because for any of these different strings s, right, regardless of how big the string s is, it's basically maximized or it's limited by however many moves we can make, right? And we need 2 things to make a move, so I think the largest possible states could possibly be is like n minus 1 strings. So it's basically O of n, so I'd probably say that the runtime is O of n squared, and I would basically say that the memory complexity is O of n. So let's run this code, let's make sure that it works. Next state plus 1, incompatible types. Oh, because I meant to say next move, sorry. Next move plus 1. Let's run this code, make sure it works. Awesome, and it does. So guys, that's how to solve flip game in Java. Again, it's a question that's being asked by Google. I hope this was helpful. If you guys found this video helpful and enjoyed it, do me a favor, leave the video a like and subscribe to the channel for more. And I'll see you guys next time. Walk up to niggas talking like me, talk. Walk up to niggas sounding like me, talk. Walk up to niggas talking like me, talk. Walk up to niggas sounding like me, talk. I walk up to niggas sounding like me.